Today we are starting with the second chapter, that is electric potential and capacitance. In the previous videos I have made the topics related to chapter 1, that is electric charges and fields. Whoever is new to our channel, you can go to the playlist section and watch the new videos related to the first chapter. Okay, and whoever is also a new visitor to our channel, you just please subscribe our channel and like our videos so that you can get the notification of our new uploads. Okay, and share it with your friends so that we can get the encouragement, we will get the encouragement to make some more videos related to the topics. Okay, coming to the class, how do you define the electric potential? How do you define the electric potential? Or what is electric potential? It will be asked for 1 mark. So electric potential at a point is the amount of work done, in bringing a charge, from infinity to that point against the electric field. So this is how you define the electric potential. Electric potential at a point is the amount of work done in bringing a charge from infinity to that point against the electric field. So in terms of mathematical form, how do you write the electric potential is the electric potential is taken as the ratio of work done to the charge moved. Okay, this ratio is taken as the electric potential. So electric potential is represented by the letter V, that is equal to work done is represented by W divided by Q. Q is the charge. From this we can write the SI unit of the electric potential, where the work done is expressed in terms of joules and charge is expressed in terms of coulomb, that is equal to joules per coulomb. This is the SI unit of electric potential, or you can also write it as volt. Volt is another SI unit of the electric potential. So another important point regarding this one is it is a scalar. Quantity. Electric potential is a scalar quantity. So what is a scalar or what is a vector quantity? You have already studied in the PUC first year classes. I think no need to remind the definition. Scalar means it is having only the magnitude. Vector means it will be having both magnitude and direction. So electric potential is a scalar quantity, right? I think this is clear about the electric potential. So next one is the potential difference. Potential difference between two points. Potential difference between 2 points. How do you define the potential difference between 2 points? So for this, let us consider a electric field. Let us consider electric field E. On this electric field E, let us consider 2 points, say point A and point B. The potential with respect to point B is VB and potential with respect to point A is VA, and the charge that is moving from A to B is taken as Q. So the potential difference between the 2 points, it is defined as the amount of work done, the amount of work done, amount of work done in moving, amount of work done in moving a unit positive charge, a unit positive charge, unit positive charge between 2 points, 2 points, between 2 points against the field, against the field. Okay, this is how you define the potential difference between 2 points. It is nothing but the amount of work done in moving a unit positive charge between 2 points against the electric field. Okay, for that we have considered the 2 points A and B. Suppose the work done in moving the charge Q from point A to point B is taken as the work done in moving the charge Q from point A to point B is taken as work done is equal to potential difference into charge. So work done is represented as W, potential difference is represented as V, and the charge is represented as Q. That is W is equal to V into Q. Okay. So this is about the potential difference between 2 points. Right. So let us have a problem on this which was asked in CET previous year. Suppose the problem is if 3 joules of work is done in moving a positive charge of 0.5 coulomb between 2 points, what is the potential difference? What is the potential difference between the 2 points? Right. When you are solving the problem, you have to read the problem twice. From that problem, you have to first write down the given values, and then you have to understand the problem what we are asked to solve here. You from the given values, and after knowing what we have to find, we can write the formula, relevant formula, which can be applied to that problem, and after that you can substitute and solve the problem, write the result with the SI unit. Well, this is the problem. While solving the problem, you have to read it twice. Okay, so here if you read the problem, if 3 joules of work, the work is given. Let us write here the solution. In solution, what are the given values? You have to write down. 3 joules of work means the work is 3 joules is done in moving a unit positive charge of 0.5 coulomb, means the value of charge is given 0.5 coulomb between 2 points. What is the potential difference between the 2 points. Right? You have to find the potential difference. It is represented as V. Okay? Already we know what is the relation between V, W and Q. That is V is equal to W divided by Q. If you substitute the value of W as 3 and divide it by 0.5, that is the value of the charge, how much you'll get? You'll get 6 volt. So potential difference, it is expressed in terms of volt. It is 6 volt will be the answer. This is how you have to solve the problem. Right. Let us go for the second problem now. The second problem is how much work must be done in carrying an alpha particle across a potential difference of 1 volt. First, before going to solve it, let us write the given terms. What are the given values here? Given potential difference is given. Okay, potential difference is 1 volt, and you have to calculate the work. Work you have to calculate. We know the relation W is equal to potential difference into Q, right? So potential difference is nothing but the value of V into Q. But Q, we don't know Q. How can we find out Q? Here you are given alpha particle. Means alpha particle is having 2 electrons. Number of electrons in the alpha particle is 2. That is Q is equal to Ne. That is 2, number of electrons is 2. Value of E is 1.6 into 10 raised to minus 19. How we got this one is, it is a standard value of E. If you multiply these two, you will get the value of Q. That is, directly substitute it here. Potential difference is V into Q. That is, value of V is 1 into Q is 2 into 1.6 into 10 raised to minus 19. When you multiply this, 16 2s are 32. That is 3.2 into 10 raised to minus 19. After solving this, you have to write the SI unit of the work, that is joules. Right? This is how we have to solve the problem. Before solving the problem, read it twice. After reading, you have to write the given values and what is to be found here. After writing all the given values, you come to know what formula can be applied here. Write that formula and substitute the values. With the final answer, you have to write compulsorily the SI unit. Without the SI unit, you will not be given the full marks. Even if you solve the problem without the SI unit, you will be given 4 marks in your examination. Suppose you write the SI unit here, this SI unit carries 1 mark. So when you write the formula, you will be given 1 mark, substitution 1 mark, final answer that will be carrying 1 mark, and the SI unit also carrying 1 mark. If your substitution is more, it is carrying 2 marks. This is how the 5 marks for your problems is divided. Okay. For the given values, if you write the given values, you will not be given any marks. The distribution of the marks takes, or it starts from the writing of formula. For formula you will be having 1 marks. This substitution carries 2 marks, and this final answer, substitution carries 3 marks. 3 marks, final answer carries 1 mark, and the SI unit carries 1 mark. This is how the 5 marks for the problem solving is divided. So you have to completely follow this procedure, so you can get the full marks while solving the problems. Next we are having the derivation of expression for electric potential due to a point charge. For this, let us consider a point P. A point P, it is at a distance r from the origin O, where the charge plus Q is placed at the origin. Right? at some intermediate point means point B, at some intermediate point B on this path carrying the electric field E, it is placed on the path between P and infinity. This is infinity. Okay. Then the electrostatic force on a unit positive charge. The electrostatic force on a unit positive charge. Say the unit positive charge is at point A. Electrostatic force at a unit positive charge is given by F bar is equal to 1 divided by 4 pi epsilon naught into Q into 1 divided by R dash square into R dash cap. R dash cap is nothing but the unit vector. It is along OA. This unit vector is along the direction OA. Now the work done, W, work done against the electric field, work done against the force, we can say against the force, electric field against the force from R dash bar to R dash bar plus delta R dash bar. You have to compulsorily write this bar sign here. Bar sign na compulsory baribeku. R dash bar to R dash bar plus delta R dash bar. It is nothing but delta W is equal to F into minus delta R dash, this value, minus delta R dash, delta R dash value, right? So delta W is equal to F into minus delta R dash. Already we know the value of F here, that is 1 by 4 pi epsilon naught Q by R dash square into R dash cap. Substitute this value here. So delta W will be equal to 1 divided by 4 pi epsilon naught into Q divided by R dash square into R dash cap, unit vector bariyodilla, minus delta R dash, right? So W becomes equal to, delta W is equal to 1 by 4 pi epsilon naught Q by R dash square into minus delta R dash. But we have to calculate here the total work done. The total work done, how will you calculate? The total work done is calculated by integrating above equation between R dash is equal to R and R dash is equal to infinity. Between these value, you have to integrate the total work done calculation. By integrating this equation between the values R and infinity, we can get the expression for total work done. So integrate this equation between the values R is equal to R and R is equal to infinity. What you will get? W is equal to, take this minus sign outside, minus integration from infinity to R. Upper limit is taken as R, lower limit is taken as infinity. That is 1 by 4 pi epsilon naught into Q divided by R dash square into delta R dash. If you integrate this equation, you will get, take this 1 by 4 pi epsilon naught and Q is a constant. These are all constants. You will get it as minus Q divided by 4 pi epsilon naught into 1 divided by R dash square into dr dash, right? This is between the limits infinity and r, right? So keep minus q by 4 pi epsilon naught as it is. When you integrate this 1 by r dash square, it is in the form of 1 by x square. 1 by x square, integration of this value is minus 1 by x plus c, right? So minus 1 divided by r dash into dr dash, plus c is negligible here, right? So it becomes minus into minus, it is plus q by 4 pi epsilon naught into 1 divided by r dash between the limits infinity and r, between the limits infinity and r into dr dash. Now apply the limits. First you have to apply the upper limit minus lower limit. Okay, so q divided by 4 pi epsilon naught, it becomes 1 by r minus 1 by infinity, right, into dr dash. It becomes q by 4 pi epsilon naught into 1 by r, where 1 by infinity is 0, right? 1 by r minus 0, it remains again 1 by r only, 1 by r, right? This is nothing but the expression for work done. Work done, W is equal to q by 4 pi epsilon naught into 1 by r. But the work done is equal to electrostatic potential, that is, this is equal to V at a point. So we have to write V is equal to 1 by 4 pi epsilon naught into q divided by r. So this will be the final expression for the electrostatic potential. V is equal to 1 by 4 pi epsilon naught q divided by r. Next you are having mention of expression for electric potential due to a short electric dipole at any point. You have to just mention the expression. In your syllabus you are having only the mentioning of the expression, not the derivation of the expression. In some books you are having the derivation also, but that is not necessary for your examination. Okay, you have to just remember the expression here. V is equal to 1 by 4 pi epsilon naught into p cos theta divided by r square, right? Where this p is nothing but, already you know, p is equal to, you have studied in the first chapter, p is equal to 2aq, that is nothing but the electric dipole moment. Electric dipole moment, right? And r is the distance, of the point from the center of electric dipole, right? And next one is the theta value. Theta is nothing but the angle between P and R, P bar and R bar, right? This is about the expression for electric potential due to a short electric dipole at any point. It is given by V is equal to 1 by 4 pi epsilon naught P cos theta divided by R square. P cos theta divided by R square, where P is nothing but electric dipole moment. It is given as P is equal to 2aq, and R is the distance of the point from the center of electric dipole, and theta is angle between P bar and R bar. Okay, is it clear? This you have to memorize only the formula here. just remember the formula and what are the terms involved in this formula. Okay, after that you have to study how the electric potential varies with the distance. So electric potential at a point, the first point is electric potential at a point due to point charge varies inversely with the distance. Okay, the electric potential at a point due to a point charge varies inversely with the distance. So we can write this using the formula V is equal to 1 divided by 4 pi epsilon naught Q divided by R. This is just for the information. No need to remember this one. You have to know how the electric potential varies with the distance. It is inversely proportional. For your convenience, I have written the expression here. Okay. The second one is the electric potential due to due to a short electric dipole. Short electric dipole varies inversely with the with square of distance, square of the distance, that is V is equal to 1 by 4 pi epsilon naught into P cos theta by R square. This is you already studied in the previous section. It is V is equal to 1 by 4 pi epsilon naught into P cos theta divided by R square, means the electric potential due to a short electric dipole varies inversely with the square of the distance. Okay, this is also, no need to remember the expression, just remember the statement here. Okay, this is how the variation of electric potential due to a short electric dipole or a point charge varies. For the point charge, it is inversely proportional to the distance. For electric dipole, it is inversely proportional to the square of the distance. Right? Is this clear? Right. So next we are having how to draw the electric potential and what is an equipotential surface. So what is an equipotential surface and what are the drawings for the equipotential surfaces? For the first one is for the positive charge and the other one is the electric dipole of two equal and opposite charges. When the two identical charges, when the charges are similar and when they are opposite charges, how we can draw the diagram for equipotential surface, right? This is all you are going to study in the next class. So today we are going to complete our class, and whoever is watching the video, please subscribe my channel and like the video and share it with your friends. Well, we'll meet in the next class then.